Hi everyone. Today I'm going to present about the Newton's law of motion, one of the most concepts in biomechanics, physiotherapy, sports science, and daily movements. These laws are introduced by Isaac Newton's and explain how object moves and how force affected the movements, etc. There are three main laws. They are first law, law of inertia; second law, acceleration, law of acceleration; and third law, law of action and reaction. Understanding these laws help us to analyze walking, running, jumping, lifting, rehabilitation, exercise, and sports performance. Newton's first law. Newton's first law, law of inertia. Newton's first law states that an object remains at rest or continues to move with constant velocity unless act upon an external force. This means a body at rest stays at rest. A moving body continues moving unless something stops it. This property is called inertia. F is equal to 0, right, and V is equal to velocity. Example, a football lying on a ground will not move until someone kicks it. When the bus suddenly stops, passenger moves forward because their body wants to continue moving. Clinical importance in physiotherapy. Patients with weak muscle may have difficulty in overcoming inertia during movements and initiation. In gait training, therapists helps patients to initiate motion by applying external force. Wheelchair propulsion also involves overcoming inertia. Sports example, a sprinter remains still until the starting force is produced. Heavier athletes have greater inertia and require more force than starting. So then law of acceleration. The second law explains the relationship between force, mass, and acceleration. It states that acceleration is an object is directly proportional to the force applied and inversely proportional to its mass. F is equal to ma. F is equal to force and m is equal to mass and acceleration is equal to a. Example, more force, more acceleration; more mass, less acceleration. Example, a kicking a light football produce more acceleration than kicking a heavier medicine ball with same force. Physiotherapy applications during the resistance training, increasing weight, increasing the force required. In rehabilitation, therapists gradually increase resistance to improve muscle strength. Muscle power training follows these principles. So, sports, fast bowler in a cricket generate more force for higher ball speed. Athlete improves acceleration by increasing muscular force productions. Then coming to the third law, action and reaction. Newton's third law says that for every action, there is an equal and opposite reaction. For example, while walking, our foot pushes backward against the ground and the ground pushes forward with equal force to help us to move. Jumping example, during jumping, athlete push downwards, the ground reaction force pushes upwards. Coming to the physiotherapy point, ground reaction force analyze is important in gait assessment. Prosthetic and orthotics are designed considering action and reaction principles. Balance training also depends on force interactions. What is the balance training also depends on force interactions. Sports importance, sprinting, jumping, swimming, and throwing activities all depends on the action and reaction of these forces. Newton's law of motion from the foundation of the biomechanics in human movement analysis. The first law explains its inertia, and second law explains force and acceleration. The third law explains action and reaction force. These principles are widely used in physiotherapy, sports rehabilitation, exercise therapy, orthotics assessment, and athletic performance training. Under these law, help us healthcare profession to improve movement efficiency, prevent injuries, and design effective rehabilitation programs. Thank you. Any doubts?